Hi guys, welcome back to In Case of Econ Struggles and welcome to another Sunday Stata tip. Today I'm going to share with you a sample program for some initial data diagnostics. I think this program is going to be really helpful. What it's going to do is it's going to put out frequencies of each string variable. It's going to put out distributions of each numerical variable. And so what I'm going to do is I'm going to put this code in the description below. Of course, you'll have to change these file paths, and I've talked about how to set file paths in a different video. I'll put a link to that video up in the right hand corner, and I'll put a link to it in the description below. But let's go ahead and get right into it, right with this dataset naming and setup section. What I'm going to do first is I'm going to tell Stata what I want to call this dataset. The reason I'm going to tell Stata what I'm going to call this dataset is that when I put out these frequencies and distributions, I want to be able to tell which frequency and which distribution went with which dataset. And so if I just use the name of the dataset, it's going to make it real easy for me to look at and find later. And so what I'm going to do is I'm going to read that data set in, and then I'm going to generate two new variables. One variable is called count, which is just going to be equal to 1 for every observation. The other is also going to be the same for each observation, and that's just the total number of observations in my data. It's going to be useful when I do frequencies and calculate percentages. Okay, now we're going to talk about frequencies first. What I'm going to do for frequencies, because I don't want to specify the name of the variable particular to my data set, what I can do is I can have Stata tell me a list of all the variables that are string in alphabetical order, and I can use that list to loop over when I'm doing my frequencies, and so that's what I'm going to do. So again, because I'm using this way to write this code, this is not going to matter what data set you have. Any data set you have, as long as it's got string variables in it, this code is going to work for you. And so what I'm going to do for each string variable is I'm just going to preserve, and then I'm going to collapse the count by that variable. So what that's going to do, and I'll show you the file in a second, what that's going to do is for each variable, it's going to tell me for each value of that particular variable, how often it appears in my data, what percent of observations that value appears, and it's going to be sorted from most frequent to least frequent. And then it's going to export that to a separate Excel sheet with the name of that variable in this nice Excel sheet called Dataset Frequencies. And it's going to make sure that I don't overwrite this file while I'm doing it. And so maybe I'll just run this. And so I'll go in here into my diagnostics folder, and you can see I've got this new file called 2020 COVID-Vax, which is the dataset name frequencies. And I'll just open that up for a second. And what you can see is that for this first variable country, again, like I said, it's got each value of that variable. So here are the different countries. It's got the number of observations that country appears in. These are the max number of observations. I don't necessarily need that variable in here, but it doesn't really hurt anything, so I'll just keep it in. This percent is out of 100. So for example, in the variable country, the value Norway appears in 482 observations out of about 86,500, which is about 0.56%. Like I said earlier, this is useful if you're trying to generate new variables based on existing string variables. So as an example, let's say I go to vaccines, and you can see that I've got a bunch of different values for the variable vaccines, and the most frequent one, this guy right here, appears about 8.8% of the time. Now suppose you want to generate a new variable where you ask if Johnson & Johnson was available in a particular country. What you can do is you can go to the top here, and you can hit data, you can hit filter, and you can hit this little arrow guy right here, and you can type in Johnson, because there's no other value other than Johnson & Johnson, and this will tell me all the values of the variable vaccine in which Johnson appears. And so this will tell you if you're trying to make that variable, you need to cover all of these different possibilities. Now it might be the case that once you get down here to like the 2 to 300 range, you say this is not worth it because it's too hard to sort of make that variable happen. That's fine, but this will just tell you, okay, if I made this Johnson variable correctly, it should be the case that all of these values for the variable vaccines get a 1 for Johnson & Johnson being available. So again, that's just an example of how this frequency diagnostic can be useful. Now we'll move on to distributions. Distributions are going to be a little different. I don't necessarily need different sheets for each variable for distributions because they're just going to be numbers. They're just going to be percentiles. I can read that in one table, so I'm just going to make one table. So what I'm going to do, very similar to your frequencies, again, it's not going to depend on your particular data set. For any data set, it's going to make a list of all the numeric variables, again, in alphabetical order. And then what it's going to do is for each one of those, I'm going to quietly sum that variable with detail so I get those nice percentiles. And then I'm basically just going to make a temporary data set where I generate a new variable that's equal to the variable name. And then I'm just going to put in all these values and percentiles from my sum command, from my sum output. Then I'm going to put it into a data set called distributions, and I'm going to use that distribution data set in order to export that Excel sheet called distributions. And so I'll go ahead and run everything together because I need that local name for data sets to come through. And if I just run the bottom part, it's not going to know that what this data set is because it hasn't heard local data set equals. Okay, so I'll just go back in. I'll pop into distributions. Maybe one thing I'll do is I'll make sure that I can read all these numbers, so I can either do the keyboard shortcut, but if you don't know the keyboard shortcut, I can just click over here, and then I can go to home, I can go to format, I can go to column width and auto fit, and it'll make sure I can read those all. Total vaccines, that's a big number. Maybe I really care about total vaccines per 100, but I've got both. Same thing for all these other variables. I will have maximum observations, I will have count because I generated them. That's fine, we can just really ignore those. The one thing to note here is for the date variable, Stata dates and Excel dates don't make sense. They don't talk to each other, they don't align correctly. So for example, if I try to make this a date, it's going to give me some really wonky numbers. Like this is 1960, 61, and so forth. That's because Stata dates and Excel dates start at period 0 at a different date. So you can't really look at this date variable and treat it seriously. That would have to be in a separate diagnostic. But other than that, I think all these distributions are helpful and just give you a sense of what your data looks like. So again, I'll put this code in the description below. I'll put a link to this video on the Global Filepath also in the description below. But if this video or these videos in general helping you out, please like and subscribe. We'll see you next time for another case of econ struggles.